Because there are so many different models that can be used during the different phases or stages of the life cycle of the project, model management is very important. In order to have a successful VDC project, we need to make sure that there is a constant updating of the model, and the model needs to be accurate. The VDC model is a repository of the project information, and we got to ensure that there is a consistent monitoring to allow the coordinated data to be generated and kept within the VDC model. And we need to have a process to resolve the design and the construction issues and get it updated into our model. There are different types of information model which we'll be talking about in the next few slides. In terms of the information model, the design intent and the construction models will form the core of the model ecosystem. Information models of varying level of development, or we call it LOD, are needed to produce the necessary deliverables at different phases of the project. If you divide the project life cycle into the design phase, the construction phase, followed by the operational phase, you can see that in the initial part of the design phase, during the conceptual stage, the model can be something that is very simplistic and typically is consisting of a visual image, so that the stakeholders can have some idea of what is it that they want to build. And it will be regularly updated along the way. Yeah. And finally, it will proceed to a design model, okay, where the detailed drawings, okay, will be carried out, or detailed modeling, okay, of the model will be carried out. And along the way, it also needs to be updated. And you can carry out value engineering, where you can reduce the cost and at the same time improve your service, okay, of your building. And you can also start to carry out the crash detection between the services that you may have during this design stage. And you continue to progress your design model, where now you can then look at maybe the more detailed collaborated design, okay, and you can start to develop a schedule and start to develop a budget, okay, for your model. So we call it the 3D model, okay, the 4D model, where you talk about the scheduling incorporated into your BIM model, and you can talk about 5D, where you are incorporating the budget, okay, into this BIM model, right? And at the same time, your model is continuing to evolve, so you need to always update, okay, the latest version, okay, into your repository. And finally, during the construction phase, you will go on to develop, okay, from your design model, okay, the construction model. So by now you have more coordinated information. You will be able to do more higher level crash detection, yeah, and you also need to continuously update the model. And you can start to have shop drawing and fabrication models along the way, because you will already have the information on hand, yeah. And you can also have a few modifications as required, okay. Also along the way, you always need to have updates. So by the time it goes to the handing over to the end user, you can have the as-built or the facility management model, okay, right? And then after that, you can have owners, facility management software, okay. As mentioned previously, the design model and the construction model will form the backbone of the information model in VDC projects. And when we are talking about the design models, these are the typical types of design model that we develop. It can be just the conceptual design to this schematic design to the detailed design. And separately, we can also develop a model okay, to look into the energy and the performance of our facilities. Okay. In the construction stage, we are looking at the construction model, which is a development, okay, of the design model, and we are looking at the different trades. Okay, you can have the carpentry, you can have maybe the rebar fabricator, maybe the masonry, so and so forth. So there are different trades. So for every trade, they also have their own construction model. You can have a surveying model, layout model, definitely the coordination model to coordinate all the different services and the building components. You can include your scheduling, so that will be what we call a 3D model. You can include your costing, that will be what we call a 5D model, and you can have a system to track, okay, your progress, so we call it a tracking model, right? Other than all these models, okay, or all these information models, you can have this dispute model that is handed over to the end user, or you can have what we call a 6D model, which is including more features for the O&M, operation and maintenance of the facilities, okay, or it can be this experience simulation models. The next few slides will go into more detail all these types of information models. So as mentioned, the design intent model, okay, it will be developed during the design stage, and it will be updated once it goes to the construction stage. Typically, the design intent model will consist of this CD, the SD, and the DD, right? So in case you're not too sure what is a CD, SD, and DD, you can come back to here again. Right? CD refers to the conceptual design, SD refers to the schematic design, and DD refers to the detailed design. So the purpose of the design intent model, okay, is to provide the design team with a tool to visualize and to understand the integration of all of the building system in a 3D space. Because the different stakeholders, okay, they are like your architecture, the structure, mechanical, electrical, plumbing, fire protection, communication, and other services, they need to have a model for them to work together, okay, or to talk about. If they were to do their own design, okay, in their own so-called private silo, there is going to be a lot of crashes and a lot of time needed to communicate, okay, and resolve issues. So if you can have one model where all the different trades can be working on, then it's easier for the different trades to understand, okay, how their design is affecting the other trades, and therefore allow the resolution of all these conflicts to be much easier. You can also have the energy and performance model. So the building's performance is measured mainly by the ability to provide comfortable conditions to the inhabitants and by the amount of energy that it consumes, for example, on a monthly basis. Yeah. So decisions made by the design team, they are going to be reflected in the performance of the building. And the design intent model can be analyzed for energy and building performance criteria and can be used to run a range of this analysis or simulation. Yeah. So this enables the design team to measure the design decisions against both qualitative and quantitative measurement. Yeah. Next, we go on to talk about the different type of information models that is developed in the construction phase. And we start with the different trades construction model. Yeah. The construction models will need to have a higher level of development because it is used for the actual fabrication, it is used for the actual construction work. Okay. It will be mainly developed by the main contractors and their associated subcontractors. Yeah, it represents the elements and the components to be installed. Okay, and forms the basis for the actual construction and the fabrication of the actual components. The models can be subdivided into separate models for every floor, for example, to keep the file size down to manageable size. Okay, So the contractors are responsible for aggregating the models and running the coordination meetings. You can also have what we call a surveying model. The surveying model is created to replicate the existing site condition. Okay, that will assist to identify, for example, clearance issue and any inconsistency with the proposed design. Yeah. So the surveying model in 3D format can be verified by overlaying it with a 3D scan, this point cloud generated. For example, okay, if you use the traditional method of construction, you need to have a surveyor, okay, or survey the site before the excavation, and then after that, the excavator maybe will start to excavate, and the surveyor will come back to do a check. But with VDC, you can make use of technologies, for example, drone, okay. Also, the surveyor extract information from drone generated data, yeah, and then after that, import the drone generated data into the excavator machine to define the excavation level plan, okay. Or then after that, the excavation machine can excavate, and so on and so forth. Then after that, you have the field operator with a smartphone to take videos of the site and send this information, okay, to the surveyor in the office. And the surveyor in the office can process the videos, okay, or the data, okay, that is imported, okay, and generate the output, okay, and compare, okay, to the as-built or as excavated condition. You can also have what we call a layout model, and the layout model can be used to operate the robotic total station. So the points from the layout model can be wirelessly sent, okay, to the layout the machine, which then finds the correct point in layout in the actual physical space. And the layout machine requires only one person to operate and to ensure that the components are correctly installed as planned per the coordinated mode. When we are doing coordination, we are actually coordinating in different areas. Of course, we need to coordinate among the different trades. And among the different trades, the typical way where we have coordination is to have meetings. Or we can call it coordination meetings, or some meetings are what we call integrated concurrent engineering meetings. Yeah. So we will then discuss, okay, the maybe a conceptual design versus the model progress along the different stages of construction. We will actually track the different issues, resolve the conflicts, okay, look into this fabrication, estimation, facilities, this delivery, look into possibility of the different stages of SP records, okay, or the site logistic coordination and scheduling. That is what we call trade coordination. But other than that, there are also other things that we need to coordinate. We will need to coordinate, for example, information, okay, or in terms of what we call a common design, okay, environment, okay, yeah, or a file exchange protocol, so that the different type of files, okay, they can communicate with each other, okay, or we call it the file interoperability, yeah. And we need to also carry out this data coordination, okay, where we so-called look at the data modeling and the tracking, the performance data, estimation data, fabrication data, and model integrity review. We also need to coordinate the different models, okay. So we need to integrate the data from the different models, okay. We need to have this content generation and management system, okay. Decide who actually owns, okay, which particular portion of the model, okay, the element ownership, okay, and the element visibility, right? So our coordination models are to link models of different trade, okay. During the design stage, the architect will operate the design intent model, but the construction stage, the main contractor then take over and operate the construction trade models, right? Coordination models are continuously revised based on the model revisions from the stakeholders, primarily used for crash detection between the systems and constructability reviews.